In this video, we will be discussing absolute values, also known as the magnitude of a number or modulus of a number in Python, including an explanation of what an absolute value is, how to use the built-in absolute value function abs, and that's including both for just numbers as well as plugging in things like expressions, infinity, or not a number value, and scientific notation as well. Then we'll discuss how to take an absolute value of a complex number and what that would even mean. And then we'll discuss a couple of tools that are in our toolbox from our math module, and that includes the math.fabs function and how that differs from abs, and finally, the copysign function in the math module, math.copysign. And if you're not sure what any of that means, don't worry, we will explain it all. But first things first, I want to go over what we mean when we say quote unquote absolute value. And if you're already familiar with that and you just want to learn how to do it in Python, you can skip ahead. The timestamps are in the description, but I will caveat that I am going to explain it a little bit differently than you might have learned, especially if you most recently learned this in middle school or high school, because it's a little bit more complicated than just saying take a negative and turn it into a positive, as your teacher might have taught you if you learned it at that kind of basic level. But for those of us still with us, to illustrate absolute value, let's put a basic number line on the screen. And as you can see on our number line, we have 0 in the middle. And then to the left, we have negative numbers stretching all the way to negative infinity. And to the right, we have positive numbers stretching all the way to positive infinity. Now, each and every one of these numbers has an absolute value, and the absolute value is the distance of that value to 0 on this number line. It's how far away each number is from 0 on this number line. And so, as just mentioned, you might have heard a more cursory explanation, or in fairness to your teacher, perhaps an easier to understand explanation of absolute value, which is just absolute value is another way to say, hey, take this number and make it positive. Always give it, take it a -3 and give me a +3. A +3, keep it a +3. And that's fine when we're talking about something as basic as this number line, as you'll see that that does give you the correct answer, but when we get to complex numbers a little later in the video, you'll see that thinking of absolute value as just, hey, take this negative number and turn it into a positive number is not going to give you the correct result with complex numbers, and so it's not really the best way to think about what we're doing here. It's better to have the mindset of this actual definition, which is distance from 0. So in order to kind of illustrate this, let's see -3. How far away is that from 0? 1, 2, 3. There it is. It's 3 away from 0. Okay, same with +3. 1, 2, 3 away from 0. And so you see how, yes, the -3 does have an absolute value of +3, but really think of it as you're going 1, 2, 3 away from 0, and that's the magnitude, that's the absolute value. Now, I just use the word magnitude, and you'll sometimes hear the absolute value referred to as a magnitude, and this makes some sense because in math there's this concept called vectors, quote unquote, vectors spelled out like that. And you can think of that as just an arrow with two properties. One property is the magnitude, or how long it is, and then the other property of a vector is the direction it's going in. So to illustrate this further, here is a snip of a quick number line I put together. And as you will see, I drew in a couple of arrows, a couple of vectors, one facing to the left and one facing to the right. And when we talk about absolute value or magnitude, we don't really care which direction it's facing. That's not the question we're asking. We're asking how far away is it from 0, no matter which direction we're facing. And so in this example, you can think of this vector that's starting at 0 and pointing to the left. It's starting at 0 and stretches out to the left until it hits this -2, and that's where we have it stopping. What's the size of this vector? What's the magnitude of it? Well, it has a length of 2. Yes, it's -2, but it has an absolute value of 2. If I were to, cut this and paste this on the right side, it would still have that same length of 2. So, what direction is it going? To the left? Sure, but who cares? We only want the magnitude of the arrow right now, the absolute value, which is 2, and it's going to be a positive 2 if we were to say this is the absolute value because it has a real, positive length of 2. And the same is true for our vector here that's pointing to the right. Starting at 0, we're taking its magnitude here, and it goes 4 spaces. It has a distance from 0 of 4. It is the size of 4 of these units. On our number line, it has a magnitude of 4. And so to illustrate this in another way to think about this, I made a graph in matplotlib, which is also what I used for the last image, though to be perfectly candid, I also marked these up a little bit in Microsoft Paint. But matplotlib is a great library for plotting graphs, which I hope at some point to make the subject of a future video, so stay tuned for that. But for purposes of this example, I'm just going to show you the graph itself, which I saved as an image file and marked up a bit by hand as mentioned. So as you can see in the title of this graph that I made, we asked the computer to plot on the y-axis the absolute value of the numbers in the x-axis. So in this example, I fed the computer a list of x values, -5, -4, -3, -2, -1, 0, and then same 1, 2, 3, 4, 5 as a list of x values, and I told the computer, hey, for every x coordinate on this list, plot on the y coordinate the absolute value of that x coordinate. And as so for example, if the x coordinate is 4, give me the absolute value of 4. If the x coordinate is -3, give me the absolute value of 3, etc. And as you can see in the markup here, we're 2 away from 0, right? And then in our x-axis, and we are also on this y-axis 2 away from 0. It's a positive 2. So the absolute value of 2 here is a positive 2 on the y-axis. The absolute value of -2 is also a positive 2. It's the same. And so we have the same absolute value for both figures. Both are the same distance away from 0, and we see that both values here in the y-axis are positive 2, regardless of whether we're giving it a negative x value or not. And notice that, we don't even have a negative y-axis here. We don't need one, because all the y values in this chart are going to be positive, no matter what x value we put in. Because we're only concerned with how far away that value is from 0, it's always going to have an absolute value or a magnitude that can be represented with a positive value, because it's always going to be some positive distance away from 0. It's not going to be a negative number. It can't be a negative amount of space away from 0. It wouldn't make sense. It would only be a positive number. And finally, notice in my title that I give an example of how you would write absolute value if you were to write it by hand with these vertical bars. You see there's a vertical line and then X and then vertical line. That's the way you would write absolute value if you were writing it by hand, or if you wanted it to be viewed by the user of your program. It's with these vertical bars. And these vertical bars are printable in Python. They're just not going to do absolute value operation for you, but they can be helpful if you want something that's displayed to your end user. So just for example, if you made a program that you're asking your user to put a number in, and then your user is going to get an absolute value out, then you might want those vertical bars. So just to show you an example, here's a 2-line program. I deliberately try to keep it very simple. A 2-line program where what we're doing is we're making our beep boop beep absolute value machine. And so let's just see what happens and compare what the user sees versus what we know happens on the back end here. So if we were to run this, you see it says beep boop, I'm an absolute value machine, enter a number and I'll give you its absolute value, right? And so say you want to put in, -9 point, some number, right? And then it prints out these very nice vertical bars, and it tells you here's the number you put in, here's the absolute value of it is, and then it gives you the absolute value, which is in this instance just the positive of this because it's just a real number. And as we discussed, that's kind of what the absolute value is going to be. So this is what the user's seeing, right? Is these nice vertical lines showing absolute value, and the user might even be thinking, yes, you're taking this and you're putting it in the absolute value and you're spitting out that. But you and I know, because we can see the program and what's actually being run here, that that's not really what's happening. These vertical lines are just for your user's benefit. So what's actually happening behind the scenes? We're making a variable called x, and we're giving our user a prompt here using the input, and the prompt is this beep boop, it's just for fun. I made it a robot voice, beep boop, I'm an absolute value machine, enter the number, I'll give you its absolute value. And then it throws on a new line just to keep it nice and clean and neat for the user. And then we're turning it into a float because, as you might have seen in other tutorials, an input like this is just going to give you a string, so we'll want to turn it into a float. And by the way, your user can break this 2 lines of code very easily by entering in text, but we're just keeping it simple. We're assuming we have a nice user that's just going to give us a number. Anyway, you can use try and accept statements and other different methods to prevent your user from breaking your program like that. But in this case, so we have our variable x, which is just the number that the user is prompted to give you, and then we're printing out this f string. F strings, if you haven't seen it before, it's basically just the f here is at the start of the string is just our way of telling your computer, hey, computer, heads up, I'm going to be throwing some variables at you in these curly brackets. So when I do that, just print the variable they represent, please. Otherwise, print all the other quoted language as written. And F strings are a little more complicated than that, but this isn't a tutorial on F strings. It's a tutorial on absolute value. But just suffice to say, that's more or less what's happening. And so then it prints out, the vertical line that we saw and the other vertical line. And how did I get these vertical lines? I Googled it and I copied it and I pasted it. That's all I did. And so, you can certainly do other things with Unicode and stuff, but frankly, the easiest thing to do is just to copy paste it into PyCharm or whatever IDE you're using. And so then the variable, which the input, then the other vertical line is, and then finally, this is where the magic happens. This is what the entire program is designed around, is this one single abs function, abs, absolute value, abs. And what is this abs function? And how do we take an absolute value with it? And that's going to be the subject for the next several minutes. So let's go back to our regular video here. And so ABS with parentheses, it is a built-in function, so no need to import anything in order to use it, and it will give you the absolute value of your number. And I'll start up here just so you can see. So what did I do here? I did ABS parentheses just with a -4, just why not, some random number, and then we're going to print it out and we're going to see what it comes up with, and it comes up with 4. And I could keep doing this here with these print statements, but just for ease of reference, I'm going to go to the console instead. So ABS of -4, we just saw gave you 4, and is the absolute value ABS of 4 going to give you the same thing? It does. It gives you 4. And are these two equal to each other? Well, remember from some of our previous videos, one thing you can do is this kind of checking statement where you put a number on one side equals number on the other and see if they're equivalent to each other, and it'll give you true, and that's not foolproof, and we've seen in other videos examples, for example, with the not a number variable where it's not considered to be equal to itself, but in this case, it will give you true. And so what does this mean? Well, these two are in fact the same, essentially the same number. They're both giving you a positive 4. So you'll notice that the computer here is spitting out just an integer, just a 4. There's no 4.000, there's no float value here. But that doesn't mean that the abs function is only going to ever give you back an integer. Rather, the abs function gives you back kind of just what you give it. So if you put a float value in, -4.0 now, then it will spit back a float value for you, and you see it's the float 4.0 as opposed to before it was just giving you an integer when you fed it an integer. So you can also put an expression inside and take the absolute value of that expression. So for example, in our video on square roots, we learned that you can take the square root with math.sqrt. Let's import math, and let's see. So if we took the absolute value of math.sqrt of 64 or something, and then there it is, it gives you this 8.0. So it took the square root of 64, which of course is 8, and then it said, hey, what's the absolute value of that? As another example, we also learned in our exponent video that we can raise a number to a power of a different number with the pow function. For example, pow of -3 to the 5th power is going to be this -243, -3 to the power of 5, -243. Okay, so it is a negative number, right? Well, what happens if we take the absolute value of pow -3 to the power of 5, and now it gives you the positive 243. It's asking, hey, what is -3 to the power of 5? Well, we know it's -243. And then second step, it's asking, okay, what's the absolute value of -243? And of course, it's positive 243. And so, what is this actually saying? It's not, as mentioned before, this isn't just saying -243, we're going to turn it into a positive. What this is saying is -243 is 243 spaces away from 0 on our number line that we still have up here. So keep that in mind. Can we do the absolute value of infinity? Well, recall from our video on constants that to get negative infinity, we do negative math.inf, right? And that gives us a float value of negative infinity. What happens if we were to try to take the absolute value of this statement? Absolute value of negative math.inf. There it is, inf, the absolute value. Negative infinity is an infinite away, spaces away from 0, you might say. And so the absolute value of negative infinity is infinity. Makes sense. So we can do it, no sweat. Well, what about our notorious not a number float value, nan value? Also remember from our video on constants that the float value, not a number, can be represented with math.nan, math.nan, right? And that gives you this nan, which is a float value. See, class float. And so even though it might just look like text, it's actually float value representing not a number. Can you do an absolute value of not a number? Well, let's try a few different things. First, let's just do absolute value of math.nan, and you'll see it does give you nan. And so you might think, great, I'm on the right track. We can definitely do it. It's just like infinity. Wash our hands. Not so fast. Because yes, this does throw back a nan at you. But what if not? We tried this negative math.nan. Well, first of all, is math.nan even a thing? Not really. See, it just gives you nan again, but just for the sake of doing it, absolute value of negative math.nan gives you nan again. Okay. Um, so yes, you can think of this as taking the absolute value of negative math.nan, but as we just saw up here, negative math.nan, it's just going to give you nan anyway. So your mileage may vary with that, but it won't throw an error back in your face. It will work for you. So that's nice. What about scientific notation? You might recall from math class or science class that numbers can be written out in something called scientific notation. If they're really, really big or really, really small, instead of saying 0.0000001 or whatever, you can represent that kind of value by saying, hey, here's an easier number to look at. Just move the decimal to the left or to the right by a certain number of places. So for an easy example in Python, instead of writing 0.02, you can tell the computer, hey, here's a 2, move the decimal 2 places to the left, please, and you do that by writing -2, and a capital E will also work, but I'm just going to use a lowercase e. And so 2e, which is similar if you were writing by hand, is maybe 10 to the power of -2, and you see that gives you your 0.02. And just to show you that it does also work with a capital E in this instance, which is interesting because often in Python you have to be extremely careful about whether or not you're capitalizing something, but in this case it'll give you the same. So 2e to the -2 is 0.02. What happens if you were to take the absolute value of that? Okay, well, it gives you the 0.02 again. You notice it does not return it to you in scientific notation. It just gives you this float value. It's not going to keep your scientific notation that you put in here. That said, I will caveat it that if you have a number that's really big or really small, Python's just going to throw back at you in scientific notation regardless, like point, 0, 0, like with a bunch of zeros. And then you see this, Python doesn't want to be writing all these zeros all the time. It's going to just throw you back scientific notation for this figure. So if you take the absolute value there, I'm just going to copy paste it because I just kind of put in a random number of zeros. And so if you take this absolute value of this figure, it's going to retain the scientific notation in that instance. But it won't if it's a number that it won't otherwise have written in scientific notation, if that makes sense. Okay, so those are some of the different things that you can do with absolute value with real numbers. Now we're going to move on to something a little cooler, which is to discuss the complex numbers, what it means, and what it means to take the absolute value of a complex number. First, though, just to quickly illustrate what we're talking about when we say complex numbers, let's think about how we might take the square root of the number -1, right? So remember, in the math module, you have these things. You have this square root function, sqrt, and this won't actually work, by the way. If I were to hit enter, it's going to give me an error, and we'll talk about that. But if I wanted to take the square root of -1, how could I even conceptualize that? Because you remember, a negative times a negative equals a positive, so no negative number times itself can give you a -1, and of course a positive times a positive is also a positive, so no positive number times itself could ever give you a -1, And so if you were to take this function with the math dot square root of -1, it's going to say, hey, math domain error. This isn't a thing. You can't do this. Well, we can. We just can't in the math module because, as we've discussed in other videos, the math module, it doesn't do complex numbers. But it does, the square root of -1 does have a value in mathematics. It's just an imaginary value. There's no real number that when you multiply it by itself, you get a -1. But in mathematics, we assign it a quote-unquote imaginary number. And despite the name imaginary, it does have real applications in the real world, which is why it becomes important. But it's called the imaginary number. And if we import the module that Python uses for these complex numbers, CMath, import C, that's the letter C, which presumably stands for complex, CMath, and then we did CMath dot square root of -1. This time it's going to work, and you see it gives us this 1J. 1J, well, I've mentioned this in other videos, so I won't beat the dead horse, but you probably learned that the imaginary number is represented with a lowercase I in some disciplines like electrical engineering and some others. So the lowercase I is already taken and they use J instead. And Python follows that convention and it uses J to represent the imaginary unit. So in this video and in other videos, if you've seen them, I also refer to J as the imaginary unit just to stick with the conventions that Python's using because, after all, this is a Python-oriented video. So every complex number consists of two parts, a real part and a quote-unquote imaginary part. The real part is the number that can be represented with real values on our number line, so this number line, or I had forgotten that I also made one in Matplotlib. But so these numbers on our number line, these are all real numbers, right, on our x-axis, and the imaginary part is one we need to in order to get our number kind of over the finish line to represent what we want it to represent, which is some number plus some other number times the square root of -1. In other words, that number times j. So for this one that we just saw, the square root of -1, it's actually, you can think of it as having a real part of 0, because you're not adding anything to it, plus 1j plus this imaginary part of just one of these imaginary units, which is radical -1, right? And so let's look at a different example. What's the square root of -64? Just to kind of stay with that example. That's 8j, which makes sense. If we have the square root of -64, it's going to be 8 times square root of -1, which makes some sense, right? It has a real part of 0, an imaginary part of 8. Well, what if we wanted to take this number and add 10 to it? So then you can't just have that be just the imaginary part. If you took this number and added a real value of 10 to it, right, all the way up here on this x-axis, you'll just have to write them as two separate things, that you can't combine them into just one nice neat figure. So the real part here is 10, because we're adding 10 to it, and then 8j is our imaginary part, with the square root of -64 in this case. And you see Python can do this no problem. 10 plus 8j, it's like, yes, I understand what you're telling me. You want this complex number 10 plus 8j. Okay. The real part, and which is this 10, and the imaginary part, which is this 8j, can be thought of as coordinates that's graphed onto an imaginary plane. Here you'll see I made a graph in Matplotlib to illustrate this concept. On our x-axis, we have our real numbers from -5 to +5. And on our y-axis, we have our imaginary numbers from negative 5j to a positive 5j. We can think of our x-axis as the number line that we just saw. If we want to stay on the x-axis and never ever move up or down on the y-axis, we can, and that gives us a big set of numbers, all of our real numbers to work with, right? So in that case, the j value is always going to be 0, right? 0 times j is just 0, so there's no imaginary part, and the x-axis is, whatever we want it to be. So if we have a positive 4 on the x-axis, um, how far away is that from 0? It's 4 away from 0. We have our absolute value. It's the magnitude of this line segment, right? Which is, 1, 2, 3, 4 away from 0. And the same thing with negative 4. It's going to be, as discussed, 1, 2, 3, 4 away, right? I don't really have the 3's down here, but, you can think of it as negative 2, negative 4. It gets you there. And so it's 4 away from 0. Okay, and the same is true if we don't have any real value and we only have imaginary values, like we saw with our square root of negative 64, for example, didn't give you any real part. It only gave you an imaginary part of 8j, which is up here somewhere. So if we had our example of 1j, just the square root of negative 1, that's just up here, right? And it's 1 away from 0. It has an absolute value of 1 still, because it still has a distance of 1 away from 0. And in fact, we can just take it. That's the absolute value of 1j. It's 1. As we just saw, it's 1 away from 0. Makes sense. And the same is true for negative 1j. It's still 1, because remember, negative 1j, it's just here. 1 unit away from 0. Okay, sure. Here's where things get tricky and where you can no longer take your, hey, just make it a positive value. What happens if we have both a real part and an imaginary part? A real part and an imaginary part. You'll see I plotted some examples here, but let's just take this one, which is 2 plus 2j. What is the absolute value of 2 plus 2j? Let's go back to our console and see. Absolute value, 2 plus 2j. Well, it's this 2.8 and change. Okay. What does that mean? 2.8 and change. I mean, it certainly didn't take either of these and turn them into a positive or anything like that. It spat out some completely other different number. What is this asking, really? Well, what happened here is we took this expression, 2 plus 2j, and we asked how far is this expression away from 0. And returning to our graph, you see this kind of line segment, this slanted line segment that I put in red here. Well, if we have the real part of 2 is the 2 and 2j, and the imaginary part of 2, which is the 2j and 2j, and we plot it on our graph, and we draw the line segment from that point in our graph to 0, then we're getting the distance. This line segment is the distance as the crow flies from this point to 0. This line segment is going to be the absolute value of our expression 2 plus 2j, because this is how far away it is from 0. To put in a different way, when we're asking our computer what's the absolute value of 2 plus 2j, we're asking it, what's the value of this line segment? And you may have guessed it from the image here, but what we've drawn on our graph is nothing more than a right triangle. And the line segment that we want to find the distance of is the hypotenuse of that right triangle. And Python actually makes it very easy to find a hypotenuse of a triangle, but first let's do it in a more manual way, just to show you with the Pythagorean theorem. So the Pythagorean theorem is saying a squared plus b squared equals c squared. So 2 squared plus 2 squared equals c squared, or hypotenuse squared, right? And so that's 2 squared, right, plus 2 squared, and that gives us our hypotenuse squared, which is 8. And in this case, we need to then take the square root of 8, which, as you recall from our video on roots, you can do with math.square root. And that gives you, hey, look at that. It is actually the same exact number. As expected, it's the absolute value of 2 plus 2j is the same thing as solving this with the Pythagorean theorem. But hey, we're using our fancy machine here. We don't want to have to manually type in the Pythagorean theorem every time we want to get a hypotenuse. Instead, let's use a shortcut here with Python. You can actually use math.hypot, short for hypotenuse, and then you feed it an x coordinate and a y coordinate. In this case, they're both 2. So this is basically saying, hey, one side of our triangle is 2, the other side of the triangle is also 2 in this case. And there it is. That's the hypotenuse of that right triangle. And it's the same, it's the same value that we've been getting this whole time. So that's great. Okay. Let's do one more example, this time with some negative numbers, just to change it up a little bit and show you one more example to walk through. This time, here we can see I've plotted this point -3 for minus 4j. Okay, so that's a -3 on my x-axis and a -4 on my y-axis, because remember the x-axis is the real values, the y-axis is the imaginary values. -3 minus 4j gets us this point right here. Okay, and you'll see once again, what are we asking when we ask for the complex number, for the absolute value of this complex number? We're asking how far away is it from 0, and in this case, how far away from 0 is going to be this red line segment right here, the hypotenuse of our right triangle that has a side of -3 and -4. And so we can do the Pythagorean theorem here again. -3 squared plus -4 squared equals c squared, square root of c. But we're using Python here, so let's just go ahead and take the hypotenuse in one fell swoop. And so that's math.hypot of, in this case we have a -3 and a -4. This is, hey, I've got a triangle. I've got a right triangle with a side of -3 and a side of -4. We're asking our computer what's the hypotenuse of that right triangle, and as you'll see, it's 5. It's a 5.0. Okay, great. Well, is this going to be the same as the absolute value of our complex number? Well, what do you think? This time it's absolute value of -3 in our x-axis, our real numbers, is a -3, minus 4j. And you could also think if this is -3 plus a -4j, but it's the same thing, right? -3 minus 4j. And is the absolute value going to be the hypotenuse of this right triangle? Is it going to be 5? It is, yeah. And this is called a 3, 4, 5 right triangle. It's thought of as kind of a special or a beautiful right triangle in math because it's so clean like that. So anyway, so that's the absolute value of a complex number. Absolute value of a complex number works just fine. It is just asking how far away is this complex number from 0, and in this case, it's 5 away from 0. All right. Moving on to kind of a different topic, the math module also has a couple of tools that we're going to discuss next. And one of these lets you take the absolute value, and it's called fabs, math.fabs, math.fabs, with these parentheses, as you'll see. And just to remind you, and I'll probably say this 2 or 3 more times, so just bear with me, but in the math module, as we've seen in other videos, it does not do complex numbers. So we're kind of done talking about complex numbers for now. If you want to take the absolute value of a complex number. Just use the abs that we've been seeing. So in any event, let's see what actually does happen when we take the absolute value using this math.fabs function. And in this case, let's import math and let's print math.fabs of -8. So what are we asking? Well, remember math, because we're going to use a math module, dot to say, hey, we're going to use this function in the math module, and then fabs in this case, or fabs or fabs, right? That's the function that we're going to be using, and then of course we need to print it out if we're going to see anything. So let's run it. And there it is, 8.0. It took the absolute value of 8. And once again, we can continue printing out statements like this, but just for ease of reference, I'm going to return to the console instead. So it gave us that 8.0, right? Math.fabs of -8, and it actually gave us an 8.0. And as you've probably seen on some of the previous videos, you know that when we have a 0.0 here, it's not an integer, even though it is kind of a whole number. It's an 8, right? But it's not an integer in Python. It's a float because it has this decimal followed by a 0. And so if you were to have had abs and you gave it that integer of -8, it just gives you an integer back. And remember, abs, you can certainly ask for a float, and it gives you a float. Abs gives you what you get, it gives you what you ask for. But math.fabs, even when you fed in that integer, it still returned a float value. And so, when we say math.fabs or fabs, you can actually think of this f as referring to the float, and presumably that's what the f stands for, though that's just my assumption. Math.fabs is going to give you the float of the absolute value, right? 8.0, even if you fed it that integer. Of course, one other difference is mentioned is math.fabs is not going to give you any complex numbers, plus 3j or something. It's gonna, 4j or something. It's gonna say can't convert complex to float. It won't do it. There actually isn't a CMath equivalent of this fabs. Just use abs and you'll be fine with the complex numbers. It works just fine. So that's kind of it for fabs. Other than that, I mean, it's basically very similar to abs. You can do an expression in fabs. If you wanted to do, 9 minus 18 or something, and then you see it gives you this 9.0, same as if you were to do abs of, 9.0 minus 18. I'm adding the point zeros just to show you it can give you the same thing if you wanted to. And so it gives you that. So, why would you use fabs instead of abs? Well, if you wanted a float value back, even if you're inputting in your program a mixture of integers and floats, but you always want to get a float value depending on what you're doing, that might make sense. Then math.fabs could be the right choice for you. You'll see some debate online about the speed of these different functions and whether that depends on if you're inputting an integer and it has to convert it to a float and then spit it back out at you versus the abs can just take the float and spit it back out at you. Maybe the abs will be faster, but your mileage may vary. It kind of depends on what you're doing. So, really, I would say the best use case for fabs instead of abs is probably just going to be if you know that you always are going to want to float, and maybe you have a situation where people are going to be putting in different integers or floats, and you always want to float. So maybe fabs is going to be the right thing for you to use. Okay, and so that's math.fabs. And how it differs a little bit, though frankly not that much from abs. And so then finally we have math.copysign. And what does this do? Well, remember how I said earlier that you might have learned that absolute value is a way to turn a negative into a positive, but then I told you that's too simple and don't think of it like that. Well, here with the copy sign, it really is kind of an easy way to change your number from a negative to a positive, or a positive to a negative, or to keep a negative negative, or to keep a positive positive. If we have math.copysign, it takes two arguments. The first is the number that we want to use, negative whatever, or positive whatever. So let's just do the number that we want to use, comma, and then the second argument is also going to be a number. And what the function's going to look at though is whether that number is positive or negative, and it'll copy, quote unquote, copy the sign of that number. Okay, and then it'll spit back this first number as either positive if this number is positive, or negative if this number is negative. So let's see some examples. As you see, spat back a float. So note that even though I put in an integer. And also see that, I put in a negative number here in our first argument. The second argument is a positive value. It doesn't really matter what this is, so long as it's a positive value. And it spat me back this positive number. What's this really doing? If you look at the documentation, with the link to which is, as always, in the description, it'll tell you what this is really doing is it's taking math.copysign x comma y, and then it's going to return a float value with the magnitude that is the absolute value of x, but with the sign that is the positive or the negative sign of y. So just to show you one more example, math.copysign of 3 comma negative 4, and that gives you a negative 3.0, a float of the absolute value, then the negative number. And so it's a negative 3.0. Notice that it gives us this float value, it gives us this 0.0, even if you're putting in integers. And so that's just one thing to keep in mind. I mean, if you really wanted an integer, you could, just convert the whole shebang into an integer, I suppose. Depends on what you're doing, and that'll give you your integer if you wanted it. And so then a couple of notes on this copy sign. So let's say you wanted to use some of the constants that we learned about in our constants video, like math.pi, with just, positive number. Whoops, well, that's because I didn't write it correctly. It's copy sign, not copy. Math.pi 1. Okay, and so then that gives you pi, or at the very least the approximation of pi that's stored in the math module with a positive value. What about infinity? Will that work? Remember, say, first let's try it as our second argument and see what happens. Remember, in the math module, negative math.inf is our way of getting a float value of negative infinity. And sure, that works. It gives you your negative 2 back. Okay, what about, some decimal? Math.copysign of, 2.000, 3, whatever, and then say you wanted to do negative 0.001. What's going to happen? Still works just fine. These are all float values, works fine with the decimal. What if we had inf in our first one? So math.copysign of, math.inf, negative 32 or something. And so what's this asking? Math.inf, it's our float for an infinite value, then a negative number. So it should give you negative math.inf if it works, and it does. It gives you negative inf, which is perfect. So that's the float of value of inf, and it's negative inf, because our second argument here was negative. Let's try something a little trickier. What if we had, copy sign of some number with 0? Okay, so now we have 0 as our second argument, And is 0, is it positive, is it negative? It's kind of right in the middle. So what's it going to give you? It gives you a positive 3. And just to prove it up, let's try it with starting with a negative number. Still gives you a positive 3. So it's reading the 0 as having a positive sign. What if it was negative 0? It still still gives you this positive 3. So then what about our not a number value that we learned about in our video on constants, which is the math.nan? Okay, so remember math.nan, positive 1 gives you nan, so you might think, oh, okay, good, this works. Well, take caution, because remember, that when we did negative math.nan, it just also kind of gave us back a nan. So what's this going to do if we had math.nan with a negative 1? Is this going to then give us a negative nan? No, it's not. It's just going to give us nan again. Still nan. And then, what about, I don't know, what if it was 3 and then not a number here? That works. Negative math.nan. So it's actually going to give you a negative value here. Okay. So CopySign also works for expressions. If you wanted to do, math.copysign of 3 times 2 and, 9 minus 18 or something. And so what's this asking? Really, it's going to solve the expressions first. So 6 and then, negative 9, and because it's 9 minus 18. And so really, because it's 6 comma a negative number, it's going to give you negative 6. Works perfectly fine with expressions too. Won't work with complex numbers because that's not going to work in the math module as discussed, kind of ad nauseum. But just to show you, can't convert the complex to float. In the math module, well, what if you wanted to do this kind of thing with a complex number? There's no separate CMath function for CopySign, but if you remember what we discussed, what this is actually doing is it's taking the absolute value and then returning the sign that you want it to be, a positive or a negative. You could just kind of split that into steps and say absolute value of, our number here. And then if you want it to be negative, you can just negate it. And that'll take the absolute value of this, the magnitude, which we discussed at length with these kinds of graphs. So it's the distance that this expression is from 0, which is this, and then just negate it. And that gives you the negative absolute value. So depends on what you're doing, but that's one thing that you could try. That could be a workaround if that's what you wanted to do. And so that concludes our video on absolute value, which discussed what absolute value means, some things you can do with the abs function, what it means to take the absolute value of complex numbers, some relevant tools in the math module, such as math.fabs and math.copysign. Thanks very much for watching.